I think came. It came. It's online now. Okay. Okay, right. Students, now we'll continue. I hope we are clear with the trigonometry part, right? Okay, 1 year is there, right? So trigonometry, applications of trigonometry, we are going to deal now. That is also called as this part is also called as heights and distances. So what we are doing here in this topic, heights and distances means distance is flat, straight, okay, linear, horizontal. Height is vertical, like this, right? So when we are using the concept of trigonometry to find the heights and distances, then automatically it is called the application of trigonometry. Suppose you join this, right? You know this is 90 degrees, and you know any angle. If you know height and trigonometry, you know this angle and height, you can find distance. Because so trigonometry will be used, okay, will be used to find actual heights and distances of the objects without actually measuring them. Okay, so suppose I want to find the height of the tower. I am standing here, right? And I know the distance of the foot of the tower with me is distance is given. And I know the angle of elevation. This is called angle of elevation. So I use the trigonometry concept tan upward side by adjacent side theta. I know this value. I know then I can find height. Otherwise, you have to actually go on top of the tower and then use the thread or else something wire or use the scale or else rope or else that is like tape like that to use. If it is in more than 500 meters, 1000 meters, 200,000 meters, how it is possible? So it is difficult to actually physically measure the height. Suppose you are knowing the height and you know the angle at which, then how much distance you are with the foot of the object. That is called the distance. Okay, that also can find by using the trigonometry. So because trigonometry gives the relation between the sides and angles of the triangle. So with every unknown object, we will make a triangle. Our object will be vertical with the base. Every right object will be makes the right angle triangle. So we can use the help of trigonometry to know the unknown or to find or measure the unknown distances and heights. So application of trigonometry is nothing but called as heights and distances. Understood now? So both are same only. Application of trigonometry is measured to use the height and distance of the unknown objects and without actually measuring them with the help of the trigonometry. Because note, why T ratio will give the relation between sides and angles with respect to their measure. Okay, So trigonometric ratios, because every trigonometric ratio, because sine opposite side by hypotenuse. Okay, theta is there. Similarly, cos adjacent side by hypotenuse, opposite side by adjacent side, and again other reverse, all the three. So there are 6 trigonometric ratios. We can use any of them to know the unknown thing, to find the unknown thing, and you can use the help of the find the height of the tower or distance of the tower with respect to base, and then measure the actually measuring them. That is called the heights and distances. So it is indirectly the application of trigonometry. So what are the angles we will use? Basic angles, standard angles, right? To use are 30 degrees, because 0 degree won't be there elevation, 60 degrees and 45 degrees. 90 degrees won't be there, because this is 90 degrees, how it will be? It won't be right angle triangle. So 0 not possible, because there is no elevation, automatically this hypotenuse will become equal to the base. So there is no height. So automatically the standard angles, what we know as values, we know 30, 60 and 45 with respect to sine, cos and tan. Because if you know these three, reverse also you can find. Are you clear or not? So 3 measures trigonometric functions, sine, cos, tan, and 3 standard angles will be taken for applications of trigonometry. So note on this part. Then we'll show actually what is the example for that. Note on. So we'll discuss some more things. Angle of elevation, angle of depression, right? This is called height, this is called the distance, you know it is. And always the measure of angle must be, trigonometric angle must be acute angle. It cannot be 90, because 90 is fixed. Either this angle can be there or this angle can be there. Suppose here object is height and the person observing is in the below the line of eyesight. This is called elevation. From here you are seeing upwards. From top you are seeing downwards. That is what that called as. That is called angle of depression. We'll discuss about that. First you note on this part. Okay, yes. Now, I think you have noted it, right? It's very simple for you to apply. Only you have to understand there will be situation in this task. Situation will be given to make a rectangle triangle, and automatically elevation or depression will be given. Then height or distance will be finding. Okay. Now suppose from a top, this is the parallel. Okay, line of parallel. You are seeing this. This is called angle of depression. So this is called angle of depression. Don't confuse with the angle. This angle won't be there. This is wrong. So this is as a parallel. This angle will be depression. This becomes automatically, because this is the transversal and these two are alternative angles. Understood now? So this is 90, right? So this is O, this is A, and this is B, and this is X. So angle XBA is equal to angle BAO, because alternate interior angles For AB, this is called line of sight. Okay, how you are seeing from top to down or down to top as line of sight. Okay, is transversal. We are using the geometry here. Understood now? So never use angle here. That is wrong point. Angle must be this. This is called angle of diffraction. This becomes automatically. This is called angle of elevation. Okay. So depression is given converted to elevation, and you can use the formula. Understood now? So this is the depression. The line of eyesight is this one, and this is observer. Observer. And sometimes here also will be their observer, right? Here also observer. So observer is seeing from top to down, this is depression. Observer is seeing down to top, that is called elevation. They are interconvertible, understood now? And this is always elevation or depression must be elevation with this horizontal, right? This is the base. And depression, this is the horizontal, this is the base, right? So there must be horizontal for elevation and depression. That is a must, remember. Here you take, this is the depression, that is wrong because there is no horizontal for this. Understood now? So note down here, note always angle of elevation or depression must be with a horizontal. Okay, this is the horizontal and this is also horizontal. This is called horizontal. And this is also horizontal or parallel. Both are same one. Okay? Understood now? So note down. This must be the structure for your conversion of elevation to depression. Note down. Angle XBA is equal to angle BAO, right? Both are same only. Are you clear? So understood what is line of sight? Angle of elevation, right? Observer is in the below and the destination is upwards. That is line, then it is called angle of elevation. And observer is above and the destination is below, then this is called angle of depression. Are you clear? So one more note is there, always note the objects standing with the base. Okay, whatever you take, tower, tree, like anything, okay, are always taken as to be perpendicular with the base or erect. Okay, they must be 90 degrees because you can't see the tree is like this, so it is not 90 like that. You should not take. Okay, whatever you take, it will be always with the 90 degrees only. You have to take as the base overall. Understood now? So this must be 90 only. Then depression, elevation with a horizontal and the rotative. That all you have to take. If you go on this standard imagination, the guidelines, because on a broader way with the respect to length, it will be, but a tree must be perpendicular to the base only. You have to take. You can't take because it is slant or else. Okay. Because you are considering the height of the object with respect to 90 degrees. Then only you are able to use the trigonometry, right? Right angle triangle. Are you clear? Note on this part. Now we see some examples. Understood all of you? Okay, right. Now we'll see an example. I'm explaining the example of first ask for the question, you will be given a question, and from the question you have to imagine and you have to plot the rough figure. No need to draw any artistic figure. Okay? Imagine a right triangle in which what is the height, what is the base, where you have to take the angle, that all. Suppose 90 degrees, you have to, I say 30 you have to show 30 only, 60 you have to show 30 only. So you are showing 60 degrees, it is wrong. Your 60 should be like this. Understood now? So that should be you have to follow the standard guideline. So take the situation and you have to understand. Then always what you have to go, draw a picture which resembles the right angle triangle, and then you have to identify what to be found, what is given, and what is the elevation angle or depression angle, what is the line of eyesight, and then object, height or distance. Accordingly, you have to use the formula. So I am saying example page number 198. Example 1 I am explaining. Okay. A tower stands vertically on the ground. So here I am writing the question. From a point on the ground which is 50 meters away from the floor, okay, from the foot of the tower, from the foot of the tower. Okay, the angle of elevation of the top of the tower is found to be 60 degrees. The angle of elevation of the top of the tower is found to be 60 degrees. Find height of the tower. Right? First read, try to understand the question. A tower stands vertically on the ground. So there is a ground and there is a tower like this. You can take the tower like this. Right? Letter it may be, it is the tower. Okay? But no need to show all these also. Tower actually you are not artistic to write it. Just you can show this as tower like this. Okay? Any vertical line. So this is tower. Stands vertically, so 90 degrees. Okay, from a point on the ground which is 50 meters away. So this is 50 meters, this is A, B, and this is T. Okay, this is a point 50 meters away from the ground, from the foot of the tower. This is foot of the tower, right? The angle of elevation of the top of the tower. This is elevation. This is 60 degrees. Okay, so solution. Height of the tower. AB is the distance of the tower, foot of the tower from observer A. Okay. Okay. B is the foot of the tower and angle CAB is equal to 60 degrees as angle of elevation of the top of the tower from A point of observation so find height of the tower. So tower height BC, that is asked here. Okay. So note down like this, you have to describe the question first. Are you clear? So note down this part. First you have to define all these things according to your figure. Then automatically this is called the line of sight. Line of eyesight. Okay. Now you want to hide this one and you know this. So what angle you have to use? You know you want upward side and you know adjacent side. Tan. Because already you know, right? So according to, suppose you know this and you want to find this. So sine. You know this and you want to find tan. Right? You know this and you want to find cos. So according to the ratio, okay, sine cos tan only is enough for you. Two ratios are same only. Two ratio of sides are same only. So you are either using sine cos tan 30, 45, 60, already I told you. You have to use it. Now, according to the situation, you have to find the height of the tower, right? So that height of the tower you can take h as h. Okay? Let height of the tower is equal to BC is equal to h. AB is equal to x is equal to 15 meters. Angle CAB is equal to 60 degrees. From the figure, triangle ABC is right angled at A. So tan A is equal to h by x. That implies 60, tan 60. Okay? H by 15. Right or not? That implies h I want. H is equal to 15 into tan 60. Right? Noted? Now what you can say from here? So h is equal to 15 into tan 60 means root 3. That is equal to 15 root 3 meters. If you are given root 3 value, substitute otherwise. Otherwise you can leave like this. Therefore height of the tower is equal to 15 into 1.73. Not 5, 109, 15 plus 10, 45. So that is the answer. Understood now? Very clear? Example 2, example 3. Now understand all of you? Clear? So likewise you have to proceed for every problem. Understood now? You have to write description, imagine the situation, draw a right angle triangle and then find elevation or depression accordingly. Because difference comes also, it becomes elevation only. Or you know, it can be converted. Right? So you what you do is that today do examples of 2 to 7 and write notes for applications of trigonometry. As homework. Okay. Tomorrow we go for exercise 9.1. Okay. doing the project. To complete by this month. All of you understood now what we discussed today? Yes? Okay, then we'll proceed tomorrow, right?